We're given the function y equals 2x cubed minus 6x squared, and we want to find all these things about it and end up sketching it. So we want any points where the graph cuts the y-axis. So y-axis, we know that that means that x is equal to 0. Substituting that in, that gives us y equals 0, so we can see the origin is where it crosses the y-axis. Now we want where it crosses or cuts or touches the x-axis. So we have for the x-axis, that tells us that y is equal to 0. So 2x cubed minus 6x squared is equal to 0. We can take out of there a common 2x squared, and then we get x minus 3 equals 0. So x is equal to 0 from this one, and that's a double root because it's x squared, so it's just going to touch the axis there. Let's make a note of that, that's a double root. And we've got x equals 3, so we have 0, 0, which we know is the double root, and we have 3, 0. We now want the behavior of the function as x tends to positive infinity. Now the leading term here, the one with the highest power, is the x cubed, and the coefficient is 2, which is a positive number. This term here will become irrelevant when x becomes very large. If x is large and positive, x cubed is large and positive, so y is going to tend to infinity as x tends to infinity. But when x tends to negative infinity, for a negative input, x cubed is negative. So this is going to be very large and negative. So y is going to tend to negative infinity as x tends to negative infinity. We now want the nature and location of any stationary points on the graph. So dy dx is going to be 6x squared take away 12x. If dy dx is equal to 0, that means that 6x squared minus 12x is equal to 0. We have a common 6x that we can take out, and then we have x minus 2. So when x equals 0, or when x equals 2, well, if x is 0, substituting back, we know that we get the point 0, 0. When x is 2, that's going to be 16 take away 24, so that's going to be negative 8. So let's look at a sign table. So we're going to have 0 first. Let's go to the left and go to the right, making sure we don't go past the other turning point. And look at dy dx. Now we know here it's 0. So what about for negative 1? Well, this would become 6 plus 12, so that would be positive. And at 1, 6 take away 12, so that would be negative. So this one goes up, across, down, and that's therefore a max. And then let's look at the other point, which is 2. And 1 is to the left, 3 to the right. Let's look at dy dx. So at 1 we already know it's negative. At 3, so that's 6 times 9, take away 36, so that's actually going to be positive. So this one is going to go down, across, up, so that one is a min. So we have a local max at 0, 0, and a local min at 2, negative 8. So, if we want to sketch this, then we know that we have an x-intercept and a y-intercept here at the origin. We know it's a double root, but that's confirmed by the fact that we know we have a local maximum here, so it's going to have a maximum just here. And then at 2 we know that we've got a local minimum, so it's going to come down through this minimum point here and then turn back up for the intercept here at 3, and then it's going to keep going up because we know y tends to infinity as x tends to infinity, and this of course was at the origin, and then this is going to come down here, and we could label this point here as 2, negative 8 as our minimum. So this is y is 2x cubed minus 6x squared.